Hello. Today we're going to talk about normal distribution. Have you ever noticed that people are pretty close to the same height in a certain area? I mean, there's variations. Some are a little bit taller or another inch or two shorter, but pretty much of our age group, we're pretty much at the same heights. Now, of course, there's this average height idea that we're all pretty close to over here. Now, some people do grow a little bit taller, but there's not as many of them. And the taller we get, whether you're 6'5" or 6'8" or 7'2", there's really not that many people that are that tall. Likewise, there's a certain, as you go shorter, there's not as many. So, once you get below 5 feet, 4'8", there's a few people, but it's pretty rare. And so if you draw this so that the height, the higher the height, there's less people. The lower the height, there's less people. But right in the middle, right in the median, there is the most amount of people. To kind of see this distribution, I like this Plinko demonstration of showing where do most fall. And there's this bell curve idea, this bell curve showing that most of them land closer to the middle, and as you get farther away, there's less and less data points. So we came up with a normal distribution, and what I want you to know today is the percentages of that. So the median, or the average, or the mean, median, mode are about the same. They're all about this line, and that's where most of the data is. And so this is the mean, median, or mode, and that's where the graph is maximized. That is where the most people are, because that's the average. That's the generality that we're talking about for this normal distribution. Now, depending on your size and depending on what your data is and how far spread apart, there's a distance here, and this distance is where most of the data takes place. So that distance is called a standard deviation. And so 68% of the values are within one standard deviation from the mean. And so of your average. So if you go a little higher, a little lower, 68%. So 34% higher, 34% lower. And so one standard deviation. So how long does that distance have to be to get 68%? That is what a standard deviation is. Okay, so then if I go a little bit farther, there's going to be less. And so now in this next section is only going to be 13.5 in each direction. And because it's a normal bell curve, it's on both sides. So 13.5, which if you include all of it, now we're up to 95% of the data are within 2 standard deviations away. So that's a big area. That's a distance. So most of our data is right there. And so 2 of those lengths, 2 of those standard deviation lengths. And then if we go a little bit farther yet, that's going to be 2% more value in that same distance of a standard deviation. So each of these are all the same distance. They're all the exact same distance, that same standard deviation. But the way the bell curve works, most of the data is in the middle, which puts very little on the end. But eventually, you're still going to get 99% because, of course, there's always outliers. There's that 0.5% on each end that is expected, to be honest. So now, this is not everything. Sometimes there's positively skewed scenarios. I'm thinking about, what if we measure wages? There might be some minimum wage that everybody's above, but most of the data and the average is kind of down here at the bottom. And then, of course, there's a few people making big-time money. Maybe they're CEOs of a company. There's not a lot of them, but there's a few of them, and their wages are far higher than the general average worker. So most of your data is kind of on the low end. That's a positively skewed situation. And if there's a positively skewed, we can flip it, and maybe there's a top end that we can't, and all the data is mostly up at the top with a few outliers down at the bottom. negatively skewed situations. So know that the bell curve, the normal distribution, does not apply to everything, but for things that it does apply to, it's amazingly consistent. So let me give you just a couple examples of things you can answer with this and how we can look at it. So Mrs. Sung gave a test in her trigonometry class. The scores were normally distributed. Okay, this is key word. For this to apply, it has to be normally distributed with a mean, an average of 85. So if the 85, that means this point right here is the 85. Now the standard deviation is 3. So that means this distance here is 3. So if 85 is the mean, then to get up into the next standard deviation away, that's going to be an 88. If I go 3 lower, then I'm going to be down at 82. And most people are going to score, 68% are going to score in between 82 and 88. Okay? So what percent would you expect to score between 82 and 88? Well, 34% is up here above it, and 34% you would expect below it. And so add them together, that is 68% altogether. Now, what percent would you expect to score between 88 and 91? Well, if the standard deviation is 3, go 3 more. 88 plus 3 more is going to be 91 up here. So now I can look at this and say, what percentage is this box right up here? This box was our 13.5%. And yes, those percentages are kind of fixed. Those are the percentages that we're looking for. So these percentages are what I want you to remember and know and write down in your notes. So 13.5% is of the population will score in between an 88 and a 91. So what percent? We would expect 13.5% to score there. And last one, what is the probability that a student chosen at random will score between 79 and 91? Well, where is 79? And so it's helpful to put all these. I'm going to go 3 more this way. That's going to give me that 79. Oh, okay. So in this section is a 13.5%, 34%, 34%, and 13.5. Add them up. That's what percent of the population is going to score in between there. And so we're looking there, and that is going to add up to, I believe, 95%. So add those percentages up. So really, you're memorizing and you're learning not these percentages. Okay? So that's what we need to know. And for these problems, it's helpful to draw the bell curve. And then just find, this is the median or the mean. And this is your standard deviation away. How far am I going to the left and to the right? And then that is going to be 68% of the data in this section up here. And then as we go farther away and farther away, there's going to be less and less data out there. So that's the idea of normal distribution. Feel free to watch it again. Hopefully I answered your questions. If you have more, let me know. Have a great day.